Hi, I'm Arjun from Wizards.exe, and in this video we're going to go over block programming. And so we're going to go through connections and configurations. So it is going to be broken up into two sections. Section 1 is going to be connecting and configuring your phones and for your robot. And the second section is going to be the intro to block programming. So again, Section 1 is going to be understanding the basics electronics in the robot electronic system, so going over the REV Expansion Hub and things like that. We're going to go how to connect both your robot controller and your driver station. If you don't know what that means, that's completely fine. You will by the end. What you need to do before configuring a robot, how to configure a simple robot, and some troubleshooting tips and tricks. So now we're going to go over the electronics. And so the electronics for a robot consists of a driver station phone, which is what's happening at the drivers, which connects up to their gamepads, their game controllers down there. It connects via Wi-Fi direct to a robot controller, which is another phone on the robot, and they can, again, communicate over Wi-Fi direct. And the robot controller connects up to the robot. Okay? So we're going to be using the REV Expansion Hub on all of our robots, which is the most current system for your robot. And sometimes it's referred to as a REV Hub. You connect your robot controller phone to the REV Hub using an OTG cable, which is a special type of USB cable. And the REV Hub has many ports on it. So you can see there's ports for batteries, motors, servos, and all types of sensors. We're going to go over, so the REV Hub on the back of it has a mini USB cable connection, and that's how you connect the phone to the REV Expansion Hub. It's a mini USB. And so you really want a firm attachment to the REV Expansion Hub, as if it disconnects mid-match, that means that you've lost control of your robot. And there's multiple different ways to do this. So REV sells a USB retention mount and cable, which comes with a mini USB to USB-A cable. And this is very sturdy and comes with a thing called strain relief, which I'll get into on the next slide. And then there's also this USB-C adapter, which is like a third party essentially. And so we recommend it for veteran teams, as it takes some work to get it ready and up and running, but it's a single cable solution. And I'm not going to go into this USB-C adapter very much. So what is strain relief? And so strain relief is essentially what holds the USB wires in modules and prevents USB cables from coming out during a match. So we really like the REV official strain relief over. We've also made 3D printed strain relief that we've designed. It's on our Thingiverse page. And the USB-C adapter is fairly new, so we haven't done too much testing on the strain relief for that. But for rookie teams, we do recommend the REV official strain relief, which is the USB retention mount and cable. So now we're going to get into configuring the phones and robot electronics. And the first step to doing this is to download the apps, which you download them from the Play Store. On your driver station phone, you download the driver station app, and on the robot controller phone, you download the robot controller app. We've already done this for you. On all of these phones, we already have these apps installed, but there are a few pointers for this. So do not install both applications on one phone, as this will mess with it. Also, don't have excess applications on your phone. So don't use your phones for other things, really. Like, don't have your personal phone on a robot. Have separate phones for these. And yeah, there's nothing really else. So you just need to connect to Wi-Fi and install them from the Google Play Store. So the next step is to disconnect from Wi-Fi. And so what you do this, I'm not sure if any of these are connected, but check your phones. You go into the settings and go into Wi-Fi.
Even if it's on airplane mode, it might be connected to Wi-Fi.
Next, you just need to check, and if it is connected to any Wi-Fi network, just click on it and hit forget. So I'm going to give you guys a minute to just check through this.
Do not turn off your Wi-Fi. You're going to need that for the Wi-Fi direct.
You want your Wi-Fi?
Put your phone in airplane mode, as otherwise it might end up trying to contact, like, do regular phone functions, like use the SIM card to make phone calls or ping a data tower. And this is for both phones. Yeah, so you should have airplane mode on and Wi-Fi enabled. When you turn on airplane mode, sometimes it automatically disables Wi-Fi, so you could have to manually turn Wi-Fi back on. Okay, so now we're going to move on. And so the phones communicate over this thing called Wi-Fi Direct. And you might be thinking Wi-Fi, meaning like there's a router, an access point, and you might be thinking it's really similar to what you have at your house. But no, it's not. It's not going through the internet or anything. It's a point-to-point communication system, meaning phones connect directly to each other. And each time you create a new Wi-Fi, each time you connect to something different, for example, you connect your phone to another phone, it's going to create this thing called a new Wi-Fi directed group. And phones will automatically connect to any previous groups they've had. This can cause problems at competition if you have multiple groups on your phones, because then it might connect to the wrong phone. So before every competition, you should clear all Wi-Fi directed groups. And so how do you do this? So open the Robot Controller app on your device. So then the next step is everybody on the Robot Controller app. There's the 3 dots at the top right of your phone. Click those 3 dots. And then go to Settings. Is everybody there? Dot, 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 and then Settings. Next, click Advanced Settings. Click Clear Wi-Fi Direct Groups, and then click at the bottom Clear Remembered Groups. Then it should say there are no remembered groups. Okay. So now we're going to name the robot controller. And so go back to Settings essentially. Click Robot Controller Name and enter your team numbers followed by a dash and then the letters RC. So I think it said you had an invalid name because it has to be all caps. If it isn't, it might do that because it makes it a lot easier at the competition when they're sorting through Wi-Fi networks. If all of them are known, yeah, and you shouldn't have any special characters. So next we're going to move on to naming the driver station. So that's the other phone you have. So open up the driver station app, click the 3 dots just like the robot controller and hit Settings. So it's very similar to the robot controller. So now we're going on to finish naming it. You go driver station name, and then you type in your name. And so for you two, just make it the same as your thing, except with a DS instead of an RC, as that refers to driver station. Moving on, so now we're going to connect the phones over Wi-Fi Direct. And so to do this, you go to the driver station, you click Settings on the in the robot controller, and then press Connect with Robot Controller, and then there should be a bulleted list. Connect it with the same robot controller, so don't connect it with the same robot controller that you are working with.
Pair with robot controller?
Yeah, pair with robot controller. Connect with or pair with robot controller.
There's one that says B-DS.
And then have the robot controller open because it might have it'll have an invitation which you have to hit OK to. So now it should say that once you've done it, it should say that the network is active and connected on the robot controller, where it says network, the top line, under the red. And on the driver station, it should have the name of the corresponding robot controller in the circle. And you're going to notice that each of the phones has a different interface. So the robot controller is much more of just white. Driver station has a much more informative interface. So now we're going to get into configuration of the robot, okay? So first you need to know how the robot is physically set up. And this will make your job of configuration easier, help with debugging. It'll make it easier for you to document your design. And before before you configure your robot, you do need to know what motors, servos, sensors you're using, what's the function of each device, as well as where each device is plugged in. So for hardware map, you need to know what the device type is. So is it a motor, servo, digital input? You need to choose a name for each device. This is case sensitive, and so best practice for us is just to not use any spaces and camel case. What module is each device plugged into is you can have a maximum of 2 REV expansion hubs on your robot. Which port is each device plugged into? Labeling wires can help with this. And so there's a spreadsheet you can see we have here an example which can help with this. For us, I didn't go through the time of making a spreadsheet for each of these robots, as most of them are just the same robot. So there's not really much there. So the first thing you need to do is make sure that your robot controller and driver station are paired. Close the robot controller and then put the battery into the robot. If your expansion hub is on, the moment you plug your OTG cable from your expansion hub to your phone in, the app should open, or there should be some request on the screen popping up saying that it should be able to open. So we're going to go change the REV Hub address. And so open up the settings in the robot controller. So that's the one on the robot, not driver station. And so open up Expansion Hub address through advanced, go to advanced settings and then do advanced address. Or Expansion Hub address through advanced settings, yeah. We're going to go to changing REV Hub address. Okay, so can you guys all sit down now? Because I can't deal with when everybody is standing up. And yeah. So, to change the REV Hub address, you can only change the REV Hub address of the one that is plugged in, because when you have 2 expansion hubs plugged in, one of them goes through USB, but then the other one you plug expansion hub to expansion hub, there's a 3-wire cable going through the RS485 port. You can only change the one that's USB plugged in, and so if both hubs do have the same address, the hub with the changed address will be the hub plugged in by USB. And so when you're in expansion hub change, you can change the address. So change it from either 2 to 3 or 3 to 2, depending on what it currently is. So yeah, one thing you're gonna notice is that the REV Hub light blinks blue. Once you first plug it in, it blinks green, and then it starts blinking blue. The number of times that blinks blue is the expansion hub address. So it should be green, and then it should blink blue. Your two are doing something else. So is that normal? I think that's normal, right? That just blinking blue?
Yeah, that means that you have to configure it.
Yeah. So that means it's waiting to be configured. And so now we're going to get into configuring your robot. And so on the driver station, select Configure Robot from the menu. Driver station, not robot controller. You can do this on the robot controller, but it's easier to do it on the driver station. So then go to Configure Robot and hit New. And then hit Scan. It'll look for all REV expansion hubs or any REV modules connected to the phone. So yeah, when you have 2 expansion hubs, each expansion hub can have an address between 1 and 12, but you should always set them so that they're different, because that makes configuration a lot easier. And never use address 1, since it's reserved for the control hub, which is a product that's not legal in our region currently in Maryland for 2019 season. So our team, we use addresses 2 and 3. And you can tell the current address through the blinking patterns of the LEDs. From when it's solid green, the number of times the blue light blinks, that's the address of your REV expansion hub. And so again, when you connect 2 REV expansion hubs together, one of them goes into the USB to the phone, and then the other one connects through the RS485 port to the other expansion hub. So don't use the UART port. Use the RS485. So all of the robots we have here do not have 2 expansion hubs, so we're not putting a wire in them. This is for competition robots that use 2 expansion hubs. Okay, so for configuration of the REV Expansion Hub, since there's only one serial number, it's fairly simple. But so what we do is we'll go and so you click on Expansion Hub Portal 1, and then you click on Expansion Hub 2, 3, or whatever your address is. Then go to Motors, and we're gonna click on the drop down. You know what? You need to know what's plugged into each port. I believe Solly knows that for all of these mini bots. So select the drop down and then give it a name for each port. So what we call them, for this training, we're just gonna call it left and right. No, because we only have 2 motors on these robots. This one was for a robot that had 4 motors, was when this presentation was written. Then you just keep pressing done until it gives you that box right there asking you to save the config, and then give it a name. So yeah, now once your configuration is successful, you should see that green box. So we're gonna go for the location of configuration files. So they're stored as .xml files on. You don't need to do anything for this. They're stored as .xml files on the robot controller phone. And so in order to, if you want to get your configuration file off the robot controller and back it up, which can be really useful for like your competition robot, so that in case somebody accidentally wipes your configuration or something, you still have it. You just go to connect the robot controller phone to your computer as a media device, and then there's a first folder, which should contain all the XML files and a folder with the block code. And so it's a really good practice to back this up onto your computer using File Explorer. We're not going to do that right now. Okay, so yeah, we're gonna go over, this is the end of the section, so concepts that you should have learned, basic wiring of the, like how it's wired, where there's motor ports, robot controller and driver station apps, how to tell the difference between them, connecting between the robot controller and driver station, configuring the phones for connections, and we did not go over making a wiring diagram today, as that would take too long. So we're going to get back into this. So we just took a quick break. And so why use block programming? And so the main reason is that it is very simple. You don't need any more software. All you need is Google Chrome, which is pretty widely available. You don't need an internet connection to anything else except for a direct connection to the phone, which the phone gives off a Wi-Fi network. You can have multiple users use block programming without any conflicts, and there's no really need for rebuilding the app, which can take a lot of time. It's really good for prototyping and testing, and you can write multiple test programs without affecting your main program. So you can build a tele-op program in less than an hour. And also, there is a blocks to Java converter, and it shows a live feed of your blocks code and what the Java code would be. So it helps you transition over to Java once you're ready. Okay, so an OpMode is essentially a program. So it's, yeah. So what is blocks programming? It's made by Google, and so it's really simple. It requires a JavaScript-enabled browser, mainly Chrome, and it's a web-based interface. And so it's visual blocks. So now we're going to connect up to blocks programming. So make sure that your driver station and robot controller are connected. And go when you click the 3 dots and click Program and Manage. And you're gonna see that there's a Wi-Fi network. It shows you a passcode and it shows you a Wi-Fi network name and a passcode. Connect up to that Wi-Fi network. So yeah, you can see it should look like what's on the screen right now. So yeah, sometimes it will say enter a PIN. Just click on connect using a security key instead. That is something that might happen. You can also go to the program and manage screen on the robot controller, but working with the driver station is a lot easier. Now there's an IP address. It tells you a web link to go to, and use the thing and connect to your driver station, and then use the password from the phone to connect. Open up Chrome and type in that IP address. So I'm going to do that here also. So you can see I've done that here. I just went to the 192.168.49.1:8080. And it opens up a screen that looks like this. And so the next step is creating an OpMode. So an OpMode is a program. It's called an OpMode in FTC. So first step is going to be to click where it says blocks up there. Then hit create new OpMode and enter a descriptive name. We're going to call this OpMode, call it my first program. So I'm going to do that here on my computer too. So I'm going to call it, I'm going to go click to blocks. Create new op. Yeah, so just use it. Create something that usually make it descriptive. I'm gonna call it first program, and just hit OK. There should not be anything in the sample drop down right now. Now we're gonna go to the next slide, and so we're gonna go over the OpMode parts. So you can see up on the screen, I have. So there's the first part where you can see it says put initialization blocks here. That's what you want to do when initialization occurs. So when you hit the init button on the driver station, it's going to run all of the blocks under between put initialization blocks here and call the .wait for start. For number 2, you can see that's what happens as soon as you hit the play button. This is what's going to happen directly after the wait for start block between that loop. And then number 3 is what happens when the program is running, is where you can see that it says repeat while demo tele-op mode is active. That's what's happening when the program is running. So we're going to start off with tele-op. And I'm going to go back to the block programming.
Can we delete this thing?
What?
The thing that's there.
What thing? This function is execute. Don't delete anything. So you can see that in here, there's a sidebar here, which is where you can get all of your blocks. All of the motors and servos are under the actuator blocks. Okay? And all of the blocks that can be used, you can find on the left side. So there are a few different types of blocks. So there are action blocks, and you can see they have that little shape with a hole, a little nub inwards and a nub outwards. They stack vertically. And they might have space on the right for a thing called a data block, which is the sideways nub. And they can be used to connect to action blocks. So data blocks can represent a lot of things like true, false, a number, a string, a word. Data blocks can refer to a lot of things. Action blocks do an action. And then there's math blocks, which allow you to put data blocks together. And so data blocks can also be used for variables. And so we're going to get into, there's the set power motor block. And so what type of block is this? What do you guys think? Oh, I went forward. Sorry. Yeah, so this is an action block, and it has a data block on the right, which is a parameter. So a data block allows you to, it has parameters. So for example, you can set, for this current block, it's setting the power to 0 through 1, or whatever you want, so it allows you to actually customize what the block does. So our first program is going to be a tank drive. So essentially what a tank drive is it moves the left motor forward or backward with the left joystick, and it moves the right motor forward or backward with the right joystick. One thing you shouldn't note is that the motors on each side move in opposite directions. So when both the left and right motors are powered forward, they're going to spin. One is going to go forward, and one of them is going to go backward just because how they're mirrored. Got it? So we're going to talk about the gamepad part. So this is only for tele-op, as in the autonomous section of the game, you're technically not allowed to use the gamepad. So if you want to take a look at the gamepad you can see there's triggers. So triggers are the analog ones, the bumpers are the... Yeah, sorry. Bumpers are the clicky ones. And so then there's also a D-pad, which has, you have D-pad up, D-pad down, D-pad left, D-pad right. You have your joysticks, which return an X and Y coordinate between -1 and 1. 0, 0 is the center. You have your letter buttons over here, which are A, B, X, and Y. And that's all of them. There's a mode button here. Don't press that, as that switches your left joystick and your D-pad. Just don't press it. It's that simple. And your back and start buttons, you can't really, and the Logitech button in the middle, you can't access. There's also the Xbox 360 controller, which is very similar to this, which is also legal. But we use the Logitech controller because it's actually widely available. The Xbox 360 wired controller, you can't really get anymore. So there's a few notes on the joystick, and the main thing about this is negative up on the joystick is -1, down on the joysticks is 1. Left is -1 for X, and right is 1 for X. So essentially the Y-axis is flipped for these joysticks. And so we're going to go through pseudocode. So do you guys know what pseudocode is? So pseudocode is essentially writing out the logic of your program. What is your program going to do without writing any syntax or dragging any blocks? And so we're going to talk about before the program starts, which are the initialization blocks. We want to reverse the right side motors so that positive power goes forward. We might, if it doesn't work and the right side block reversing doesn't help, we might want to try reversing the left side block instead. When the program starts, we don't really want to do anything because we want it all to be in the loop block. We don't have a servo to move immediately once the program starts. And then when the program is running, we want to set the left motors to the left joystick Y value times -1 because, of course, the joystick Y value axis is negated, and we want to do the same for the right joystick and the right motor. Everybody got that? Okay. So now the first step is going to be to drag and select the DC motor and set it to reverse. So I'll show you how to do this. You're going to see a lot of different blocks, so don't be scared by all of the ones here. So I'm going to click on Actuators, DC motor, and then I'm going to set the right direction to reverse. So you guys see that?
Yeah.
So one thing you're going to see is right there, all of these ones right here were all pertaining to the right motor for me. So you can actually do a drop down here. I'm going to click away. There's a drop down right there, which you can change the motor, and you can change a lot of different things. You can see that right there? There's a drop down so you can change it. But again, first we're only setting the right motor. So you can see we've selected the motor, and so there might be multiple motors. So depending on the robot you're using, the ones that we have here are only using 2 motors, 1 left, 1 right. Sometimes you'll see left front, right front, left back, right back. So just select all the motors on your right and make them reverse. So now this thing says repeat for right front. The motors that we're using do not have that, but you can use Control-C and Control-V to copy and paste your code. So I'll just do a quick demo of that just in case there's a little confusion. You can click Control-C, Control-V, and it pastes it, and you can have the same block. I'm going to delete that right there because it wasn't needed, as I'm only coding on a robot with 2 motors.
Right click and press duplicate.
Yes, you can. There are multiple ways to do it. We use Control-C, Control-V just because it's quicker, in my opinion. And also, if you have a trackpad, sometimes it can be harder to right-click. But yes, right-click, duplicate works. Okay. So now we're going to set the motor power value from the joystick. And so first step for that is to drag a set motor power block. So I'm going to switch over to Chrome. And you can see that here we can go to Actuators, DC motor, and set the right dot power to, we're just going to do the set dot power to 1. And you can see there's the put loop blocks here. We want it to be right there. And that's in the program. So it should look, your program should look like this. So we're going to do that. We're going to add a negative sign to the motors because our joystick is reversed. So I'm going to switch back to Chrome. And so under math, there should be, you see that negative sign right there? I'm going to drag that over and I'm going to put it there. It replaced the one with a 9. That's fine right now since we're just going to put we're going to put a joystick value there. But so we'll put the negative block there. So now we're going to set the motor power to the value from the joysticks. So you go to the Gamepad section and select Gamepad 1, right stick Y, and snap that in. So I'll demo that too. So we go here, we go to Gamepad, and we want Gamepad 1 dot right stick Y. So where's that going to be? So you can see it has right stick Y right there. So that means right joystick Y. And so I just dragged that in. And now we have our full thing for the right motor. Now we're going to complete the program. And so essentially what we're going to do is we're going to copy and paste that for the left motor. If you have 4 motors, you might need to copy and paste it a few more times and just adjust that. So you can see here, I'm going to click that block, copy, Control-C, Control-V.
We put it right under.
Yes, so put it right under. Change it to left and left stick Y. So that's what the whole thing looks like for 4 motors. Again, you wouldn't have the right back and right front up there. You wouldn't have like right front and those 2, but you guys get the gist of it, right? So that's what happens for 4 motors. Are you all good? So now we're going to actually put this into the driver station. So I'm going to go back to Chrome. And you have to hit the Save OpMode button. So you see at the top left where it says First Robot Controller, right under that it has Save OpMode. Make sure you click Save OpMode, otherwise you're going to lose all your work. There is no autosave function in blocks as of now. So you have to hit Save OpMode, Save Often, and then you're going to see it says Save Completed Successfully to the right of it once you've done that. And so now we can leave this open or we can exit it. I'm going to leave it open. But on the driver station, now you can open up your driver station. So we're going to get into your driver station now and connecting up your gamepad so that you can run it. Okay? Driver station wiring. So here I have an example of driver station wiring. This is for your competition robot where you're going to have 2 drivers most likely. Some people only have 1. But you have your phone. So you have your phone here, and it connects with an OTG cable right there, right there, and we have a USB hub. We prefer using the Anchor hub. It has to have at minimum 2 ports, but Anchor makes a very nice 4-port hub, which I've actually found it to. Sometimes there's a broken OTG cable, and plugging in the Anchor hub will actually make it work, just because it's a very nice USB connection. Because the OTG cable is very loose sometimes. And then gamepads, you either need a Logitech F310 or an Xbox 360 PC wired controllers. Again, Xbox 360 PC wired controllers, they don't make them anymore. They're very hard to find. So on Amazon, they're like $40 each. While the Logitech F310 are $25 retail, and you can get them $15 if they're on sale. So one thing to note is that there's a switch on the back of your Logitech F310 controller. And it says X and D. All of ours are already configured in the correct way, but you want to make sure that it's flipped onto the X side. So essentially what it does is it's 2 different. You don't see it on ours just because we have a case covering it, but it is there. Essentially, it's the Logitech F310 controller is marketed towards gamers who also want to play their retro games. So X input is a newer form of communication, while the D stands for direct input, which is used on much older consoles and also the Nintendo Switch. Configuring a driver station. So first, just put your phone on the driver station. You can see I've done it here like this. We printed out our custom phone mounts and stuff, so we just screw them into the driver station. So basically now you plug in the OTG cable to your phone, and then there's the start button on the gamepad. So you hit start A. So I'm going to do that on this camera right here. So give me 1 second. So you can see I just plugged in the OTG cable right there. You can see that. Yeah. So now I'm going to open up the FTC driver station app and press the start button and the A button. Now you can see at the top of the screen, there's the gamepad right there. And when I move anything, the gamepad starts glowing. So that means that you know that your gamepad is connected. One thing to note is that if you want to put it as gamepad 2, you hold start and B. But we're all using gamepad 1 today. You can do start B for being driver number 2, gamepad 2. One thing that's worth noting is that you should zero out your gamepads. So if I hold start and A, if I hit both of these at the same time, but then I have a gamepad, like a joystick pressed, that is very bad. So that essentially means that it thinks that joystick down is 0, which means that your robot's always going to move. So make sure that the only 2 buttons you're touching are start and A when you press start A. Otherwise, you might end up having problems and your robot might not be working as it should.
Hello, I'm Sarthak. So Arjun just mentioned talking about how to zero out the gamepads. So one of the ways you can check that is if you go onto your robot controller phone, and once you initialize your gamepad, you should see all of the coordinate information right here at the bottom of the screen.
I got this.
Oh, yeah, right here at the bottom of the screen. So it shows you what all the values should be. So on this phone, all the joystick and trigger values are zeroed out, which means that you've initialized your gamepad properly. But if you press down a joystick or press down one of the triggers, then a value like 0.6 might show up, in which case you know that it hasn't initialized properly. So that's one thing you can check when you're running a match.
Now we're going to troubleshoot a few steps for troubleshooting in case it doesn't come up. Make sure that the switch is in X input mode, not direct input. Try and unplug and replug all connections in. Try restarting either the driver station phone or the driver station app. And then finally replace the OTG cable for a different OTG cable. Checking the gamepads, you first have to move something on the gamepad before the text of all zeros shows up. You move a joystick and then release it. So running in op mode. So the first step is to choose your op mode. So there's 2 arrows in the middle of the screen. You see there's one on the left, one on the right. The one on the left is for autonomous modes. The one on the right is for tele-op modes. Click that arrow and then choose your op mode. Okay? I'm going to do that on my screen too. Here you can see. And then I'm just going to hit first program. Okay. Then you hit initialization, the init button to run all the initialization blocks, and then hit the play button to start running the loop blocks. So try out this program. Wait 1 second though. First, one thing to note again, Dira here is having this problem is that everything is reversed. This means that the motor that you reverse is the wrong motor. So try instead reversing the left motor instead and retrying it. Yeah, try using the left motor reversed instead. In order to stop the robot, you just hit the big stop button, the square in the middle of the driver station. Okay, so yeah, we're going to get into troubleshooting in case anything went wrong. If they went in the wrong direction, either check the wiring to make sure that your left and right motor are correctly bound, or just reverse the left motor instead of the right motor. If they didn't move at all, make sure that the gamepad is connected, so make sure that at the top of the driver station you can see the gamepad. And if one of them didn't move, check the motor connection. Or also check if you did left stick Y and right stick Y instead of both right stick Y. Yes.
Now can I turn off my computer and will it still be able to run the program?
Yeah.
But it won't be if I change it on the computer, it won't change.
Until you hit save, it does not change anything.
Okay.
So yeah, you can now this program is on your robot controller. You can do whatever you want. If you want to edit it with a different laptop, you can. But the last person who hits save is the one who that's what's running.
Okay.
So you could technically have 2.
The last person who hit save when it was connected.
So you could have technically 2 laptops running, and both have the same program open, and then whoever hits save last is going to be the one whose program is run. But I would not recommend that because that does not sound like a very good idea.
People start fighting.
Yeah. Okay, so we're gonna go into zero power behavior now. So each motor has a zero power behavior. So there's brake or float. And so I believe the default for the REV Expansion Hub is brake. But so we're gonna try changing it to float and then brake. So I'm gonna show you how to do this, and then you guys can do it now. So you put the code in the initialization section. So you go to DC motor, set zero power behavior, which should be here. And so we're going to set the zero power behavior to float for both of them. Yeah, so let's set it to float. You see what I've just done on the screen, and save the OpMode and try it out. And so take a look as soon as you just let go of the try moving it forward and let go of the joysticks, and observe what happens. So now try changing it to brake. Just so that you can see this contrast between brake and float. So I'm just gonna go here, and I'm gonna click it and select both of those to brake. Okay? And I'm just gonna hit the save op mode and then test it. So I have a quick video here just to show you the difference between brake and coast if you didn't notice it already. But here we go.
This is the robot with coast enabled. As you can see, when I let go of the joysticks and a power of 0 is set, the robot does not stop, but it rather coasts till it stops. This is the robot with brake enabled. As you can see, as soon as I let go of the joystick, the robot jolts to a stop, and it doesn't coast.
Now let's see. You saw how the robot moved differently, where it coasted after movements, and so where would float be useful? Because you can understand why brake would be useful in drivetrains easily, because if you need to line up and be precise, you probably don't want to float and use float. So it's really useful in places like sweeper, shooters, linear slides if precise positioning does not matter, or any place where a really hard stop would damage the gearbox. So, because if you try and run something to high momentum and then stop it, you could actually start grinding some gears. Everybody got that? Yeah. So, we're going to get into variables now. A variable is essentially like a memory location to keep track of a value. So you can essentially have a few values that you keep track of, and we can set it and set it again and again. And we're going to create 3 variables called right power, left power, and max power. So I'm going to do that right here. Just because you guys this is going to be your first time. Give me 1 second. So you're going to see on the left side there's variables. You hit the create variable button. And we're going to call it, I'm going to create right power first. Okay, so I've created all 3 variables here. You can see that, right? Yeah, sure. Okay, so now I'm going to get back to the PowerPoint presentation. We're going to create block code to slow down the robot, because sometimes the robot is a little bit too fast, right? Oh, do we need one called max power? So yeah, you've already created the 3 variables, left power, right power, and max power. So the first thing we're going to do is set the max power to 0.5. So that means that your robot's always going to be running at half speed. And then here, we're going to set the left power to the gamepad left stick Y times max power, negative of that. And we're going to do the same for right power. And then we're going to set the left back and right back to their respective powers. So I'm going to show that in Chrome right now. So here. So you can see I'm going to drag a variable out and put it in the initialization block. I'm going to bring a math block out, and I'm going to bring a number out. And this is where I'm going to set the max power, which I'm going to set to 0.5. Okay? Everybody good? Oh, yes, thank you for pointing that out. So you can choose the drop down and set it to max power. So the next thing we're going to do is we're going to set the left power and right power to the joystick times the max power. So I'm going to get another set left power block here. And let's see. I drag that here. I'm going to bring a math block out. So then I bring the multiplication block out. And I'm going to bring the left stick block directly from the set power block to there. So that gives us exactly what we had previously. And then we're going to multiply it by the max power. So we go to the variables menu and choose the data block for max power. Okay, so has everybody got that so far? What we're going to do now is we're just going to copy the set left power block here. So copy and paste it. I'm going to drag it right under. I'm going to set that to set right power, and I'm going to change that to right stick Y. Got it? Next, I'm just going to delete that right there. One thing that I just noticed is that we're actually on a slightly old version of the APK on all of our phones, including the one that I'm using. So the only difference in the block programming interface is the fact that there's no live feed of what the Java code is, which would be on the right side of the screen. There is still an export to Java button, but other than that, you still should be able to go through this video. So the next thing we're going to do is we're going to go to variables and get the data blocks for left power and right power. So I'm going to set left to left power and right to right power. So I'm just going to drag both of those down there. And so now that we've finished, this is the finish of the program. So this essentially finishes off this program, and it makes it so that we're essentially multiplying all of our gamepad speeds by 1/2 so that the robot moves at half speed and is easier to control. So now I'm just going to hit save on this OpMode. So one thing that the people here have been having trouble with is sometimes the init button doesn't respond after they hit save OpMode and then try and init. The solution to this is just to reselect the program by hitting the arrow on the right and just select the program again, and then it'll work. That's just something. So you can see I have a final code here, but we've already finished this. So now there's this thing called telemetry. So one thing you might want to do is debug your code, and essentially you might want to know what your variables are. So this can be helpful for more complex code, where say there's a variable that's not working, you want to know what value it has. So there's this thing called telemetry. So at the bottom of your driver station, you're going to see that there's a status robot is stopped message. So you can see right there, the bottom in the black, you can see it says status robot is stopped. Well, that's where telemetry goes. So we're going to put telemetry for all 3 of these variables. And so let's see, I'm going to show you how to do this. So we're going to switch to Chrome. And it's going to be, I'm going to just collapse that. It's in Utilities and then Telemetry. And then you see it here. So we're going to be using Add Data. And so just drag out a Telemetry Add Data block. Okay? And so there's 2 Add Data blocks. There's one with a key and text. And there's one with a key and number. So I just dragged this into the wrong place. So I'm just going to scroll down quickly. So I want to bring that left up, but then I also want to keep the telemetry.update. Okay, so there's a version with a number right here, and there's also a version with a key. So we're going to start off by dragging out our variable. So I'm just going to bring that, collapse that, go to variables, and I'm going to take our max power and drag that where it says number. Then where it says key, I'm going to write max power. So once you've got that telemetry block in, I'm going to copy and paste it twice. I'm going to put one for left power. I'm going to change one to left power and one to right power. So I'm just going to scroll down. and I'm going to get one for left power, one for right power. So I've gotten 2 of them in. I'm going to take that one, left power, and then I'm going to choose the drop down on that and make it left power. And I'm going to do the same for the other one, except make it right power. So that's essentially a data label. So it's going to print out max power and then like a space, and then it's going to print out your value. One thing I'm going to talk to you about is the emphasis of the telemetry.update blocks. There's the telemetry.update block that you can see at the bottom, and this is essentially updates it. So if you do anything before the telemetry.update block, then it's going to happen on the next cycle. So always make sure to have the telemetry.update block at the end. Okay?
Yes.
So now we're going to get into if-else blocks, but first I just want to test out this program now because I just want to show what it does. So we're going to switch over back to Chrome, hit save op mode, and then we're going to run this op mode again, except I'm going to show the telemetry that's outputting this time. So I'm just going to run this. You guys don't run it yet just because audio is going to get messed up. So you can see I'm reselecting it. I hit input, init, play, and now you can see at the bottom of the screen, there's values that are updating for max power, left power, and all of the sort, which are those things at the bottom of the screen that are changing. And so you could see it shot out a little bit. That's just because of the fact that it can get to a really weird number. That's a very long decimal point. Now we're going to get into if, do, else blocks. Task that we're going to go over is trying to make it so that when you're pressing a bumper or trigger, it goes at half speed, but then when you're not pressing it, it goes at full speed. This is something that many drivers will actually have in the competition. And so one thing that I'm gonna just say about if, do, else blocks is if you hit that little settings button right there, it's gonna open up this little mini block programming menu that allows you to actually customize your if, do, else block. And so I'm just gonna switch over to Chrome, and we're gonna actually no. So that's the program there, but I'm gonna write it in front of you just to help you out. Okay, so actually that's not the completely correct program because I forgot to put variables. But we're going to continue with this program, okay? So I'm just going to scroll up here and zoom in a little bit, which is covered by the camera on the video recording. And so you can see we have the set left power to this and set right power to this. So I'm going to go to logic, and we're going to use an if, do, else block. Because we want to do if the bumper is pressed, then we do the half power. Otherwise, we'll do full power. So we're going to go to Gamepad, and we're going to go to, we're going to use the left bumper. So I'm going to just drag that up here. Okay? So next step is to drag this up here, and so you can see that dragged a little bit too much.
Wait, you have to put the whole thing in an if block?
No. So I'm going to drag this back out and drag it. That's just how blocks works. Got that?
Wait, 1 second though.
So you need to drag those into the left.
If, do, set left power.
So you can just drag what you already have. So the next thing we're going to do is I'm just going to copy this left power block, and we're going to make it a little bit, we're going to remove the max power. So I'm just going to drag that section out, delete the multiplication because we don't need that, and bring that back in. Once I do that, I'm going to copy and paste that and just change it for right power also by just changing the stick and the variable. So that's what it should look like. So now just remember to save the program, and then we'll just try it out. And so with that, that's all of autonomous we have for this section. There's still one more section that we'll record sometime later. But I'm going to go over something that I haven't seen any documentation on yet. So far, I've not seen a single piece of documentation other than the fact that it exists. And this is the offline blocks editor. So one thing you might be curious on how it works. And the offline blocks editor is very simple. It's essentially the same thing that you have. And the first step is to just download the offline blocks editor. After you hit the blocks button, hit download offline blocks editor. And this is going to download a zip file. And one thing that's interesting is it is bound to the current robot configuration, meaning that it's bound to the selected robot configuration. So yeah, you get the gist of that. It has whatever is active, it's only going to have those as the options. Then extract the zip file and open the index.html file in the zip file. It gives you a page that looks almost exactly like this right here. A few notes about this editor is any op modes created like on the phone are not going to download with the editor download. So you should also download the .blk file if you plan on working on it offline, meaning when you're in the editor, there's an option to download the op mode. You should do that. Another thing, again, is it looks almost exactly the same as when you're connected to a robot controller, except the first onBot Java and manage buttons are grayed out. There's also no auto sync, so you still have to hit save op mode whenever you want to save your op mode. And yeah. So that's essentially all of that section. So there's a few concepts you should have learned, like how basic block programming, running an op mode, understanding the gamepad, controlling a motor based on gamepad inputs, zero power behaviors, if, do, else statements and loops, and telemetry data for feedback, as well as encoders and run to position. So I have a few additional documentation on block programming, including the REV Expansion Hub Blocks Guide is actually a very good resource, this one at the top. It's a very long PDF and it goes in depth into almost anything about block programming. And so there's some credits. Thank you for watching. If you have any questions, email Wizards.exe or leave a comment below. Thank you.